Today's sponsor is 1Password Extended Access Management. Bring all your unmanaged devices, apps, and identities under control. 1Password Extended Access Management ensures that every user credential is strong and protected, every device is known and healthy, and every app is visible. 1Password Extended Access Management is available now to companies with Okta and coming later this year to Google Workspace and Microsoft Entra. Check it out at onepassword.com/XAM. That's onepassword.com/XAM. Welcome to Heavy Networking from the Packet Pushers. I'm Drew Conry Murray here with Ethan Banks. On today's show, we talk about designing a network to support hybrid cloud deployments. That is, building and operating a network to interconnect the big three U.S. public clouds, so Google, AWS, and Azure, as well as on-prem infrastructure. And this is all to support a variety of applications and workloads. The design had to meet several requirements, including trying to reduce cloud egress costs, integrate with the on-prem data center, and minimize latency. And by the way, you also need to be able to monitor and test these networks. And this isn't just a whiteboard discussion. Our guest had to design and build this network. Heavy Networking is pleased to welcome Kaon Thana, staff network engineer at the New York Times. We're going to talk about design options, the network architecture, dealing with public cloud costs, why you're going to need BGP chops for cloud networking, lessons learned, and more. Kaon, welcome to Heavy Networking. Can you just start us off with talking about the design challenge that was presented to you?
Hi, Drew. Thanks for having me. I've been listening to Heavy Networking for, I think, the better part of a decade, so I appreciate being here. And I'd love to talk about the design challenge that you described. In my organization, we have multiple application teams or development teams who have built applications or production workloads in multiple cloud environments. So maybe one example would be GCP, Google Cloud, as well as an AWS. Or there might be a team that has shared services in one cloud environment that another team will have to access and have a conversation across. Mm-hmm. So in the past, when these teams had to communicate to each other, generally the communication was done over the internet, over public endpoints. And that scales just fine, but if it happens a lot, you want to step back at the problem and look, well, okay, we have these multiple teams in these different cloud service environments, as well as we have an on-prem data center. How can we create a cohesive solution to make it maybe less complex and also make it more secure and have more control over the conversations?
Was it just about sort of, costs, about having to have, AWS, an AWS workload talk to a Google workload, or were there other things that you thought we can do this better than just going over public internet?
Yeah, of course. So cost is definitely one of them, right? So as you mentioned, the cloud egress costs of transferring traffic across the public internet over direct connections, there is a cost advantage there, but also there's some security exposure there, right? Even though it is encrypted traffic with web application firewalls, there is increased security exposure, and you also have really no routing control, right? So if there happens to be a dispute on the internet between one provider and another, you really have no way of managing, these connections. So those were the key things that we wanted to help.
And one thing to know about this design requirement, so we're talking about three different public clouds, but we're also talking about the New York Times. You have a data center in the East region. So for folks, sort of making a map in their head, pretty much everything we're going to be talking about is happening in this generalized U.S. East region. We're not talking about a solution that has to span, across the entire U.S. or globally. Correct.
Yeah. I mean, when the problem is first approached to us as a network team, and you think of the large scale of this problem, right? But you want to break it down. You go back and you start asking questions like, where is the majority of this traffic and what are the traffic patterns? And then you realize when you kind of look at the 80-20 problem, really 80% of the workloads we're talking about here of these app-to-app workloads are US East to US East, right? So whether a team has a GCP build out that needs to talk to something in AWS, it's mostly going to be US East in both cloud providers, similar with Azure. And as you mentioned, also, what do we currently have in place? So we have a New York data center. How can we leverage this? And in that data center, we do have existing on-prem direct connects to Amazon. So how do you put all these pieces of the puzzle together to create a cohesive solution? And that's how we start to break down the problem. As well as, we mentioned the US East to US East, but also how much traffic are you talking about? If it's less than a gig of traffic, yeah, okay, you could probably do all this with like site-to-site VPNs. But if it's more than 100 gigabits of traffic, well, now you're talking about different situations. When we analyzed the traffic patterns, we realized we could probably get away with multiple circuits of 10 gig connectivity. That should be enough to cover our use case. It wasn't a ton of traffic, but also wasn't such a little amount of traffic. So that was kind of the sweet spot we found. We could focus on those two key things, the 10 gig circuits and the US East regions, to really come up with the solution.
So multi 10 gig circuits like meshed between your different cloud presences or aggregated as a multi-link of some sort?
Yeah, so it would be where we believed one 10 gig circuit should be enough to cover most of the traffic, but obviously with having redundancy, you want two 10 gig. But then if we did want to do load balancing, which I did end up doing on these connections, you can now spread that out even more. So if you had, let's say, for example, 4 10 gig circuits, which I did end up installing, now I could run maybe at 25% capacity on each circuit and just do some load sharing across with room for overhead in the future, because as we onboarded more and more teams to this solution, you realize, well, you have to keep in mind the traffic, the egress, how much traffic you're putting on these pipes, right?
Another thing you mentioned was data egress charges was part of the concern. Did you actually avoid data egress charges in this scenario?
So it's complicated. I guess there's, trying to understand the charges of cloud environments is difficult. But from what so the best way I can kind of describe it is the solution that we put in place had some fixed monthly costs, which we had to pay for the interconnecting parts. However, the egress charges that we did from cloud to cloud, instead of going over the internet and the cost that involved, you pay less based on if it's a private connectivity or if it's what they consider on-prem or dedicated connectivity. So it's a lesser charge compared to internet egress.
Okay, so not straightforward. It's like you said,
Right.
It's complicated. Effectively, it's an ROI analysis. You got to break out the spreadsheet and kind of figure out how this is going to work.
Exactly. It's not either or. It's not like, oh, you pay no charges versus you have to figure out, okay, well, if you're so here's an example, right? So let's say you take 1,000 terabytes of traffic and you do the AWS calculator of how much would that cost over public egress or versus, let's say, a transit gateway egress or transfer cost, I should say. And then there's a percentage you save there, and then you say, okay, well, on this percentage, is this enough to make it worthwhile to implement these extra circuits, and does it add up? So you have to make that call at some point.
So you came up with a few different options to solve this problem of connecting these disparate clouds, each of which had pros and cons. And I guess I'd like to go sort of through them. Option one, you were going to leverage that corporate data center we mentioned in New York. Can you kind of walk us through what that looked like?
Yeah, sure. So even stepping back, even before that, my kind of, and I talked to my manager, Alex, about this too, even before we approached our stakeholders with solutions, I realized, in some cases, maybe senior network engineers will walk into a meeting of like, oh, shooting from the hip, like, oh, we could do this or we could do that. We'll figure out, we'll make it work. We're the network guys, it'll work. But I thought really for a project like this, you kind of just want to hash out a few options, maybe 2 or 3 options that are legitimate, and then make your recommendation based on some pros and cons. So as you mentioned, we took a step back and we looked at it and we said, all right, well, since we already have an on-prem data center, can we leverage that? And what would that look like? So we have a direct connect to Amazon. Can we just provision a couple more circuits, through our New York data center? And what would that mean? And that would be pretty quick also to do. But at the same time, if we did that, if you realize if most of the traffic is going from Virginia to Virginia, does it really make sense to hairpin all this traffic back up to New York and then back down to Virginia? To me, as an engineer, that really didn't make sense. So even though that was an option, it was like my least preferred option, right? And then on top of that, it's like, okay, well, you have this cloud native app, and now we have this on-prem data center that, maybe we have some of our own SLA factors. Maybe we need to do network upgrades or maintenance windows. And good luck trying to find a maintenance window in general, making sure the newsroom's not, not in an election cycle or whatever, trying to upgrade routers. Now we want to throw even more stakeholders on top of these maintenance windows. So it didn't really make sense for me to add more different parts of the business unit to an already existing, WAN network.
Mm-hmm. Okay. Yeah. So avoid that hairpinning. So then that sort of led you to option two, thinking about colo space in the same literally geographical region of the public cloud providers, which I think in this case is probably in Virginia.
Yeah, so obviously, like as a network engineer, this would have probably been my favorite option, right? So you build greenfield, you build it all yourself, you have the most control. Where you would, as you mentioned, you go down to Virginia, you find two colo providers who are, diverse, and you get four new layer 3 switches, and you just go, you run with it. Now there are some negatives to that because it is a lot of upfront costs, right? And you have to also just build out your own data center, essentially your own colo. It's not really something that we're doing every day or in the business of doing, right? But so there's some negatives to that. And actually, additionally, this was just after post-COVID supply chain issues. So I think at the time, even for us to buy 4 new layer 3 switches, whether it was from Cisco or Arista or Juniper, would have probably taken like over a year.
Wow.
So really, I didn't think that was a great option.
Yeah, that makes sense. That's a good context. Having to wait a year to get this project off the ground is probably not going to be welcome.
I mean,
Right.
not a bad design, though. I mean, straightforward enough, I guess. I mean, colo, I don't know. If you're not in the business of dealing with colos and building out those racks and you got your standards for that, I guess that could be a thing. But it feels, I mean, going back to what you're saying as an engineer, it's like, oh, I don't want to hairpin stuff through New York. Can't we just keep it all in Virginia? Because then no latency overhead. I mean, it feels desirable. I mean, was it really was the tipping point to go against that? Just like, I can't get equipment.
Yeah. I mean, like I said, if it was fully my call and probably the network team's call, we probably would. But it just felt like there was too many hurdles there, and it would be a harder sell, I think, to do. But yeah, I mean, and that could still be an option in the future, right? If we realize, we'll get to, I guess, what we did go with. But if we realize that this solution is too ephemeral, that maybe colos is the better solution in the long run. And I think equipment nowadays, I haven't checked recently, but I think it's easier to get equipment now. At least I hope it should be easier to get.
Yeah. Supply chains. I don't think it's solved everywhere. Last I heard, there are still some supply chain issues, but overall, it's a way better scenario than it was a year and certainly 2 years ago. So what solution did you end up with, Kaon?
Yeah, for sure. So the third option, and there was actually one more possible option, which was the cross cloud connect that Google had just come out with, but that was kind of just too new for me at the time, so that I kind of put that to the side. But we ended up going with the partner interconnect. So the way that works, I'm sure you're familiar with it, but the way that works is Google and Amazon and Azure have a list of recommended partners who they integrate with, where essentially you rent a router in their colo location and you get a slice of their router. You get a web interface. You have your virtual router, and you can create these virtual circuits to different cloud providers. So it was kind of like meeting in the middle, where you're still kind of using a cloud service provider. You have this router, and you're just using it as a transfer spot, right, to connect these multiple cloud providers. And then you could also get your own circuit, direct connect circuit from your data center into these virtual routers as well. So that's the solution we thought would be the most flexible. And it kind of followed the cloud first mindset. And some other, the other positives about that actually was, as I mentioned before, it's kind of a fixed cost, right? So every month you can decide, I'm going to spin up these 2 routers and they're going to be running for X amount of time, and these virtual circuits, and it's a fixed monthly cost. There's no extra data charges for however much bandwidth you pass across there.
And it's a software driven circuit buying process, if I remember right. You can basically pick this thing off a menu and it stood up very quickly. It's not like the old days where you'd call up and you needed a circuit provisioned and it was going to be months before you got that circuit lit up.
Exactly. Very flexible in that sense. And it actually, even during the proof of concept process, I would go in the portal and I would see, okay, yeah, you claim you have these in your maps, but I would go and try to click and try to order that circuit that I wanted from that location. because in some cases, maybe 7 other customers also ordered those circuits, so they might not have the availability. So that was part of the, the choosing process is, can I actually go in and click in and get these circuits on demand as I want them?
So the appeal of this then was it was almost like the colo solution in that you are local in Virginia, so you're reducing that latency. But instead of having to operate and run gear yourself, you're essentially, you said, getting like a virtual router. It's already in a colo that you're not responsible for running the hardware. You're just maintaining that virtual instance.
Exactly. And you're still responsible for setting up, high availability. So you set up a dual router, dual routers and multiple connections. But yeah, actually all the back end worrying about critical updates and code updates and all that stuff. So you lose some control, right? You lose some of the nerd knobs, right? You don't have it's like you have a full Arista or Cisco CLI, right? You're getting BGP, you're getting, some AS prepending, and you're getting prefix lists. But yeah, it's essentially a web interface of a router, and it has an API as well, where you can make calls to. But yeah, and you're essentially just getting a slice of those router instances.
So that's an interesting question. Were you getting like a virtual quote unquote flavor of a router platform you were familiar with, like a Cisco or an Arista, or was it sort of a stripped down? You didn't really care what it was. It was probably sort of a white box design.
The vendor we went with, yeah, we don't. I don't know. I think they're running Cisco in the back end, but I couldn't tell by the platform. All we see is a web interface with BGP neighbors and the location of the router and IP addresses. So it's a very abstracted cloud-like service.
They could be spinning up a VM on Linux or something, and it's to you. If BGP is really the primary service you're getting and some IP addressing, who cares? You wouldn't know. It's all automated. They've built their product set on probably automating this so that you go pick it off the web menu. It spins up an instance and gets it secured, and you go to configure BGP, and there you go.
Yeah, for sure. I mean, one of the reasons why I think it might be the Cisco model of well, I forgot the model that they use that has the virtual that you can build multiple tenants routers is because I think every once in a while they do have maintenance windows where they do need to upgrade code. So that's why I'm assuming it's probably that. But again, I'm just guessing. Could also be Arista or Juniper. But yeah, or like you said, it could be a Linux, white box, whatever solution. And the good thing is it doesn't really matter to me as long as the uptime is there.
Well, I was thinking about the Linux component just because there's so many different BGP daemons that are out there. I mean, they could be building this all on open source and have it fully automated with all different kinds of tooling or custom scripts they wrote themselves. It could just be that simple, or it could be heavy, like you said. It could be a big solution depending on scale requirements and a lot of reasons. But yeah, interesting. What was the service that you bought? Can you say?
Yeah, of course. Yeah, we ended up. We looked between Megaport, Equinix, and Packet Fabric. Ended up POCing a few of them. I ended up going with Megaport routers. But again, it's kind of like a month-to-month thing. So if for some reason the service, stops working as expected, I could always shoot on over to one of the other competitors. I think that's the one positive about a service like that, right?
What led you to go with Megaport?
So there's multiple reasons. I mean, like we kind of talked about before, making sure that the resources were available, that they had the routers and the cross connects available in the regions that we wanted, as well as a key thing is the API support and the Terraform support, right? So you do want to think cloud first. You want to think automation first. I know, Ethan, I see your AutoCon shirt on. Network automation is key, right? So you always it is my mindset anytime and I try to tell other folks in my company or in enterprise tech, like if you do go with new vendors, one of the number one questions should be, obviously security, but also do you have APIs? Do you have automation? So it seemed like that they had that. And as well as, you want to make sure, you do some Googling around, you search Twitter and Reddit and all that stuff, and you make sure there's no major issues. Nobody's reporting major issues. And so you do due diligence. And and they seemed right for this project.
Hop into the Packet Pusher Slack and go Anybody having trouble with a Megaport? I'm looking at them. Tell us the truth.
Yes,
Because you will get people that'll respond if things have been good or bad, for sure.
For sure.
Yeah.
Let's pause for a brief message from sponsor 1Password. Imagine your company security is like a college campus quad with those well-maintained brick paths between the buildings. Those are your company-owned devices, IT-approved apps, and managed employee identities. And then there's the paths people actually use, the shortcuts through the grass, around the fences, and behind buildings. Those are your unmanaged devices, shadow IT apps, and non-employee identities like contractors. And most security tools only work on those nice brick paths, and a lot of security problems take place on the shortcuts. 1Password Extended Access Management brings all these unmanaged devices, apps, and identities under your control. It ensures that every user credential is strong and protected, every device is known and healthy, and every app is visible. 1Password Extended Access Management solves the problems traditional IAM and MDM can't touch. It's security for the way we work today, and it's available now to companies with Okta. It's coming later this year to Google Workspace and Microsoft Entra. Check it out at onepassword.com/XAM. That's onepassword.com/XAM. And now back to the podcast. Yes, okay. And knowing you, you are into network automation. So it sounds like one of your criteria for the vendor was it could support sort of the automation frameworks and tooling that you've got in place.
Well, especially for this project, right? Because if you think about it, the folks who came up to us with these requirements are developers and they're DevOps guys. So I didn't want to reset to the old paradigm of kind of the old school network engineer who creates some solution behind a black box, and then next time you need something, okay, open a ticket, I'll get back to you in 3 days, throw it over the wall, and here's your thing. I wanted it to follow those principles of DevOps and platform engineering and create a shared repository and create as many of the resources as possible in a fully visible, transparent way so that, realistically anybody could see how the system is working.
So like a DevOps team could maybe get their hands on this and, provision or change things as they need, or that at least it's easier for you to do that if they come to you with requests?
Both, for sure. Yeah. So if a scenario occurs where a new team needs to be onboarded to the connection, they could open a PR against the shared repository and say, well, this is what I want to happen, and these are, I think, the resources I need to provision, and then through that PR phase, a CI/CD pipeline would kick off where a plan will happen, and it'll say, well, if we did go with this proposed change, this is what would get modified, this will get deleted, or this prefix list would get altered, and is this acceptable? And then I could go in and approve it, and then when you go to apply it and merge it into the main repository, then the dry run, it would turn from a dry run to an actual execute, and the changes would get made. So that was the goal of this deployment.
A practical question about connectivity. So we've got the rented router, and how do you connect your network into this thing? Is it a tunnel, or is there actually physical connectivity where the rented router's got to be in a facility you're in, or?
Yeah, no, you can provision circuits from your data center, just like you would a direct connect to Amazon, for example, or to Google. You would just provision a circuit to the POP, and then go on the portal and create the port, essentially the physical port. It wouldn't be a virtual port at that point; it would be a physical port, and you could just connect it just to the routers.
The catch being you've got to have whatever provider you chose would have to have a presence in your building. Is that true?
Or you build a circuit out to wherever their closest POP is. So in our case, if the closest POP is 32 Avenue of Americas in New York, you could just build. You can hire out whoever, Verizon, Comcast, whoever, Hurricane Electric to just get a circuit from your building to the closest POP, or go all the way down to Virginia if you want. I mean, if it's on net, you could do that as well.
Okay, so that goes back to more the traditional telco stuff, where that could add some lead time in, depending on things.
Yes, for sure. So that did add, but the good thing, especially being in this part of the country, is the lead time for circuits isn't so bad, right? Especially if you're on net and fiber already exists, you can get those on-prem direct connect circuits fairly quickly. But yes, but you could do it in stages too, right? Which we did end up doing, is you do the cloud to cloud communication first, you get that up and working, and then whenever you want to integrate your on-prem data centers, and you could do that at any time as well.
Yeah, okay. So let's maybe dig into the architecture then for each of the public cloud connections that we're dealing with again, GCP, AWS, and Azure. What do these look like?
For sure. So we can start on the GCP side. So our teams, they each would have a specific team might have a project in GCP, and then maybe multiple projects for example, maybe for sandbox or for staging and for production. And then within those projects, they would have virtual VPCs, right? And for the most part, these VPCs, these networks, their primary subnets were running on private IP space, like let's say 10.x space, and they were not conflicting, which was good. So when I see that and I see these candidate lists of projects, we're thinking, okay, what if we create a hub account, a networking hub account in GCP, which would act as kind of a hub and spoke architecture where we would VPC peer from the hub account in networking to all these teams that requested access, right? And then from
the idea
there,
being everybody that's on a spoke has got to go through the networking hub. So there's going to be security policy there and so on. Can this spoke talk to this other spoke? It's got to pass through that centralized networking hub. Is that the idea?
Yeah, that would be the idea, exactly. And it's if you want the access, it's not like just every account has access to every account. It's concept of least privilege, right? So somebody would have to make a request to VPC peer to the networking hub, in GCP. And in that hub, like you said, there's policy and we have the two GCP routers, and following the best practices for high availability there, you put them in different regions. And in GCP land, you have to create 4 partner interconnects for 4 nines of availability in different availability zones. So a lot of documentation reading there and going through that documentation. And okay, so now you have your connections, and then you connect those 4 interconnects to your partner routers, right? To your third-party routers. So now whenever a new spoke comes online, you can now just update a prefixes and say, all right, here are all the AWS routes, here are all the Azure routes, and here are all the on-prem routes. Here you go. You have connectivity now. Now, the one thing that we did run into, I mentioned before, on the primary subnets for the GCP accounts, there was no conflicts, which was great. So you could VPC peer them. So I did the first team, and then I went to go do the second team, and then you miss a spot because you realize there's a secondary section where these teams are running internal Kubernetes sections, workloads, and these are using like very large 100.x spaces. And you realize, well, these are just internal. Why do I care? These are peering. Let me just filter these out. Like, I don't care if these are overlapping. But GCP wouldn't let you peer these spokes to the hub if there was overlapping ranges. So that opened up a whole other can of worms because you're like, okay, well, you're not going to tell the app teams to re-IP. And so what else can we do here? So at the time, the GCP reps were like, well, there's this new feature called NCC, which was beta at the time, called Network Connectivity Center, and you can do route filtering there. So try it out. It's in beta, or it was just general release at the time. So I tried it, and it seemed to solve the problem. But then it opened up another problem, which was even though I could now connect multiple teams to the same hub account, even if they had overlapping IP space, I couldn't transit traffic outside of that hub account. So I couldn't send their traffic to on-prem or to Amazon or to Azure, which defeated the whole purpose. So I was like, well, that's not what I want. So NCC was out. So back to VPC peering, and then we decided, all right, well, let's just bite the bullet, and it's kind of first come, first serve. The first teams who get on will VPC peer, and then any further team will just have to lower their secondary ranges and just not be conflicted with another team. So that's kind of the workaround we did on the GCP side, at least.
And so, yeah, that's the next question on the AWS side. Then, how is that different? Because it sounds like we kind of have the big 3 providers, but slightly different architectures and everywhere. So we got GCP. Yeah, tell us about AWS.
Yeah, exactly. So the good thing with AWS is there was already a fairly mature setup there where we have the multi-account setup with transit gateways, and every account kind of already has kind of a hub and spoke architecture, if that's what you want to call it. They already had transit gateway attachments there. So in my mind, I'm thinking, all right, when I'm drawing out this diagram, that should be pretty simple. We already have the hub networking account. All we have to do is in AWS land, you really only need 2 connections for 4 nines of availability or 5 nines of availability, and in a different location. So we just have to provision 2 new connections to the partner interconnect routers, and we should be done there. But there was one kind of issue that we ran into there, which was in AWS, the transit gateway transfer costs were still very high compared to, it was still very high. So if you take that 1,000 terabytes of data in a month, if you ran it through the AWS transit gateway calculator, the cost savings was not that much. It was like 30% cost savings, but it wouldn't really matter because you were basically a wash at a wash. So we figured, okay, well, what can we do here instead? So back to the 80-20 rule, you look at all the heavy hitter of accounts. So you say, well, even though we have dozens of accounts in Amazon, there's really only like 5 or 6 or 10 or whatever that are really doing the most of the load. So can we take these accounts and can we connect them to this solution another way that's a more cost-effective way? And the answer to that was using VPGs or VGWs, they call them in Amazon, VPN private gateways. Is that or virtual private VGW? I'm just going to call it VGW. So in Amazon, if you transfer this traffic across these dedicated VGWs per account, it's something like a 60% cost savings. So that meant that we could take these heavy hitter accounts, and it was only a handful of them. I can create a Terraform, 100 liner, change the AS number for each account, and hand it over to the dev team and say, hey, in your environment, install this Terraform. Now you're going to create a new VGW to my networking hub account. I'm going to approve you. Now you have your own dedicated pipe to this private connectivity project. You still have your transit gateway connectivity, so nothing's changing there. This is just an additive thing. But any traffic that's destined for maybe these special connections to Azure, to GCP, can go through these VGWs, and you're going to save 60% transfer costs there. So that was kind of the workaround there.
Now, does this mean if another project pops up that does need this connection across multiple clouds, that you would have to set up another one of these VGWs? Like, does Correct. This mean that's some work on you to do these individual setups?
Correct. And that's, again, going back to what we were talking about before with the pipeline is if it's one page of Terraform that just requires a couple of changes, it's easy enough to scale out, right? So okay. It's not like you have to go in everybody's account and start clicking buttons and for every single time, right? You can kind of scale it out with infrastructure as code that way.
It's not too onerous then.
Right.
Okay.
But yeah, and the other thing that does actually involve is, okay, so now you go from in Amazon land only having to create 2 connections. Now you're kind of creating a parallel architecture, which kind of adds complexity, but there's no way around that. So now you're creating additional, connections in Amazon that are kind of for these dedicated heavy hitter accounts in addition to the transit gateway for the rest of the accounts. But we thought that was a good trade-off, right?
We should talk about your Azure architecture as well. But then I got a follow-up question. Tell us about how Azure was set up.
Sure, and we could be quick on Azure because that wasn't a huge amount of traffic. It was a few teams had some instances there here and there, but it's similar concept, hub and spoke. VNet peering where you create 2 express routes to a hub VNet. There was one kind of hiccup we ran into where we had already had some site-to-site VPNs there, so that had to kind of be torn down and re-added after the express routes into the different hub VNet. But fairly following the documentation, fairly straightforward. So the Azure architecture, same concept.
Now, was this straightforward because you just had fewer developer environments working in Azure, and so it was just simpler to plumb up, or was it something about how Azure has built out its networking capabilities that made this simpler?
No, yeah, you're probably right on that. It was probably just simpler for me because it was also the last piece I did of this project. So it was also kind of like, okay, I've been through this before. I've read all this documentation, and there was less workloads. And the funny thing with Azure is actually their nomenclature it actually threw me off. Now I'm kind of used to it, but it kind of throws you off. I don't know, nothing against Microsoft. Just it was a little different. It was just a little different. Everything's just a little bit different in all these environments that just kind of throws you off.
So here's my follow-up question, Ken. Now that you described the three different architectures and the plumbing you had to do to get all these guys talking here, um, why not a multi-cloud networking solution of some kind? There's a bunch of vendors out there that do it. Proximo's top of mind to me because they just briefed me recently with a new announcement. Of course, Aviatrix has been out there, and there's other ones too. Why not a solution like that kind of paves over a lot of this complexity? It doesn't make it go away, of course, right? But it kind of hides it behind a unified interface. So you're dealing with them and not all the stuff you were just describing having to deal with.
Yeah, I mean, that was an option. I did look into them a little bit, into companies like that. I couldn't tell you an exact reason why or why not. I know so one of the use cases was it would require building, I believe, an appliance in every account, or at least in the main hub accounts, which I thought might be a little harder to get approval from other teams, right? It's one thing asking a team to change an endpoint, to say, oh, hey, you're pointing to this DNS server now. I just need you to point to this DNS server, versus asking a team, hey, I need to build an appliance in your environment, kind of thing.
You mean a virtual appliance?
Right. So I think one of the solutions did require that, but it's definitely nothing wrong with it. It just, at the time when I was going through all these options, this just seemed like the less complex way to do it. But maybe it turns out that it wasn't.
All right, so we got the big three public clouds you're working with, but you also have this virtual router that everything has to connect to. Can you talk about what that architecture looked like?
Right. Yeah. So right, two routers in two different locations in Virginia. And A and B locations, meaning they have resiliency. And they're essentially just kind of input in and out points, right? I mean, obviously you're running BGP on them, and we could talk about that. And there's some prefix lists here and there. But for what it's worth, they're just monitoring the bandwidth going in and out, and they're just connection points. And I mean, pretty straightforward in that respect.
And again, to bring it back, it's if I've got a workload in Azure that needs to talk to a workload in AWS, it's going to run from Azure through to my virtual router at this partner location and then back into Google.
Exactly. That's exactly how it would work.
So talk to us about BGP. BGP would be the common routing protocol across all the clouds. And so you think, I know BGP, they speak BGP, this will be easy. But it was not so easy, according to our show notes here from UK on.
Right. Well, so the funny thing is, like, everything we're kind of talking about, I think most cloud admins can kind of figure out, this stuff, right? A lot of it is kind of putting puzzle pieces together or Legos together. But I think really where kind of a network engineer would, really provides value to a project like this is understanding BGP, right? Because that is what all these cloud service providers use. So in the sense, okay, so what design decisions do you make around these routing protocols? How do you decide which way your traffic flows? Or as we talked about earlier, do you use ECMP or not? And then more importantly, how does your traffic fail, and how does it fail gracefully, in the case of unexpected outages? So, obviously one key thing with BGP is you do want to enable, BFD, so for fast failover. And the interesting thing is different cloud providers will have different timers. So in GCP, you get a 1,000 millisecond by 5 multiplier, meaning you take a hit for 5 seconds. But in AWS, you get a 300 millisecond by 3 multiplier, so you have a sub-second failover potentially, right? So that's 900 milliseconds. So that was kind of an interesting thing. So if you were going to test maybe failing over an Amazon circuit, and then you realize, okay, well, that was a pretty quick failover, and then you fail over a GCP circuit. Well, okay, why did that take longer? So something to dig into there. And then at the same time, you also have to understand, route manipulation. So how do you influence traffic? Maybe you only want your traffic to go via this virtual router versus another one. How do you influence that? So every cloud provider might have different ways to influence that. There's the longest prefix match, meaning more specific versus more broader subnet ranges. And do you want to use that to send traffic the way you want to? Then you could also influence policy with BGP communities, meaning from my router, I tell Amazon or Google, hey, in this community, I want you to alter your policy using this community that I'm sending you to prefer my routes going maybe out of my New York data center versus my Queen, data center in Queens, for example, as an example, right? So there's different ways of manipulating route priority and preference. And you want to understand what's happening. Like you don't want it just to be a mystery to you. So I do think understanding that is very important.
So it's not, your point is, I mean, those are fundamentals of BGP that you were describing there. Communities and longest prefix match and so I mean, longest prefix match is fundamental to routing, period, of course. But you mean it's not just nail up the BGP peering and exchange routes and off you go. It's you need to be able to manipulate routes for purposes of traffic steering or whatever, maybe not traffic steering, but where you want routes to enter and exit and so on. And to influence that, you got to have service provider level knowledge of how to impact BGP's decision on where it's going to forward routes, how it's going to weight routes, what it's going to announce as it sends routes out, and so on. And if you don't know all those things, you can't engineer the routing solution with BGP that you might want to engineer.
No, that's exactly right. And especially if there's more complexities down the line, right? What if you do add another data center somewhere on the East Coast, or you do start thinking about West Coast traffic? So having a good understanding of BGP is very important. And we even talked about before with load sharing and ECMP, what are the positives and negatives of doing that? Does it make sense to have non-deterministic route paths where you don't really know which way your routes are taking because you want to do load sharing? But that also gives you more resiliency in terms of outages, right? So if 50% of your traffic is going across two links, if one of the links happens to fail, at worst you're failing over 50% of your traffic versus 100% of your traffic. If you're only pointing BGP to only use one link versus two. So all those concepts have to be kind of kept in mind, right?
So once you've got all of this in place, you need to monitor it and operate it. Did you find differences between monitoring public cloud networks versus monitoring your on-prem?
Oh yeah, for sure. I mean, in my view, all this stuff we're talking about is one part of the project, but I really don't think a project is done until you think about all the supporting systems, and visibility is really key because you don't want to take on projects like this and just have them, accumulate tech debt or just be kind of institutional knowledge. You want full visibility. And as you mentioned, it's a little different with these cloud environments where you're not just pointing like an SNMP poller to a router and saying, okay, go grab some metrics and here's some bandwidth and here you go, right? There's I don't even think they support SNMP. They probably don't. So it's just more like, streaming telemetry and APIs. So in my case, just started writing some API scripts that would grab the data I wanted. So check the BGP status, check the bandwidth. And then, I could tell the application teams, hey, here's a login to this portal, go look at it. Or I could say, well, I see you guys are using, for example, Datadog, and I see you have your dashboards for your app. Well, in your dashboard, I'm going to add a graph that shows this private connectivity graph of the traffic at this time, so that if you do have a problem in the future, like between 1 and 2 p.m., you could look at these graphs and say, well, it looked like the network was okay, or it looked like this private connectivity pipe was okay at the time, right?
You're trying to eliminate it's the network's fault by giving them a graph they can look at. I love that.
Well, that was my goal. And in addition to that, definitely creating kind of synthetic testing and baseline testing. So I had my own servers, I'm like, oh, okay, I can have my own app servers in these environments, and I can run pings and iperfs and HTTPS across and create these baseline tests. So I can say, well, at the time that maybe there was a problem, well, my HTTPS requests came in and I didn't lose any packets, and it looks okay to me, so maybe check, the load balancers instead, or something else that could go wrong. So definitely wanted to have these baseline, tests in there to make sure that this solution worked as expected.
Now, since you're using APIs instead of SNMP to get this information, could that tie into your existing, network monitoring solutions, or do you have something sort of set off to the side for this, cloud architecture that you developed that's just for that?
Yeah, no, we were able to integrate. So a lot of the network polling that we'll do now, it has support for API. So we were definitely able to integrate our existing systems with that. So that wasn't an issue. I mean, obviously it's a little bit of a different paradigm, right? Because we still have SNMP holders, because I think every enterprise network engineer is probably still running SNMP somewhere. So we definitely still have that. But in the same time, you're able to add that on. And then more importantly, which I know we kind of talked about visibility, but also day two operations you want to think about. And we kind of talked about the pipeline, but you want to think about, all right, everything works day zero and day one. But in the sense where if tomorrow a new team wants to get onboarded to this solution, again, you want to have that full end-to-end visibility, and how do you accomplish that? And think about those operations, because you don't want to just to kind of create toil, right?
Right. I'm curious, as you were designing the solution overall, did you bring app or DevOps teams into the process in the design phase to find out, like, what do you folks need out of this? Or did you feel like this is pretty much a networking thing and we can handle it as long as we're meeting, some basic requirements on, throughput and performance?
No, definitely in communication with our delivery engineering team and our DevOps folks, and a lot of the stuff I'm talking about is essentially borrowed from their platform systems, right? Because as a network team, we don't work every day. We try, but we're not working every day in GitHub and with platforms and pipelines. So I try to see what they're doing and definitely get their input and say, well, I see you guys use Terraform a lot, so that seems like that's the best way to approach this, right? Or I see you guys are using Datadog for graphing this data. Okay, I'm going to try to do the same thing. Instead of build my own thing and force somebody else to use it, it's better if you kind of assimilate to the existing products that other people in your organization are using, because that will just make it more widely adaptable, right?
In a lot of what you've designed here and put together, what the vendor is that running whatever network operating system kind of disappears. I don't know what shop you guys are at the New York Times, if you're Cisco, Arista, or Mix, or whatever you are. But as you're dealing with this cloud stuff, you made the point a few times that it kind of doesn't matter. Has that all changed your vibe on how you feel about particular network vendors? Like, if it forwards packets and has the configurability I want, and I can get the data back out of it I want, either from an API or telemetry or whatever, I really don't care what the NOS is. I care about the network functionality. Is that something that went through your mind?
Yeah, for sure. And especially with picking a network as a service provider, right? One of my questions was not during that process, what routers are you running in your data center? I mean, maybe it was, but it didn't register whether I asked it or not. It didn't, like you said, it didn't really matter. Now, if I was building it myself in a colo environment and having to purchase equipment myself and getting budget for that, then it probably would matter, because there's other factors to take into effect there, right? Now you have to say, okay, well, what is the team comfortable with in the CLI, or what APIs are more friendly? But if you're just commissioning a cloud service provider, like you said, whatever Google is doing in the background, or Megaport or Packet Fabric or whoever, like you said, it's just as long as the APIs always return the correct value and there's no bugs in there, right? And which could happen, I guess, potentially, but as long as it returns the right value, it's good.
So let's talk about outcomes. You went through all this work. You got this all set up. Did you meet the design requirements you set out for?
Yeah, I mean, overall, we did have to do some audibles here and there, as we talked about, but yeah, for sure. Overall, as far as lowering, monthly cloud traffic costs, somebody who keeps an eye on those told me it's lowering the cost, so I believe them. Since I couldn't comprehend those mass spreadsheets of costs, so I got a thumbs up. So all right, fine. But then the stuff that I do know about, which is improved security posture and more control of routing, obviously we did that because we were able to limit the amount of public endpoints out there, and we have more control of how our traffic is going from point A to point B. So that's also an improvement. And from a network engineer standpoint, definitely saw better network performance because as I kind of mentioned before, when I created these baseline tests. So if I spun up an EC2 instance or a compute instance with two NIC cards, with a public NIC card and a private NIC card, and then if I did an ICMP or an HTTP test across the links, On the public side for ICMP, maybe I would see, let's say 21 millisecond response time. Then when I set up the private links, I would see 13 milliseconds. So immediately there's, 7 to 8 milliseconds, savings right there on ICMP. Now, granted, we're not doing high frequency trading or anything, so it probably doesn't really matter, but it's something, right? It is definitely an improvement. Right. It is graphable, improvement. And with HTTP, the interesting thing is, we did see on the, maybe a 10 millisecond improvement. But what I noticed interestingly on the public side, the graph for the HTTP requests, they would be very jittery and they would oscillate a lot. So at one point, maybe an HTTP response would come back in 55 milliseconds, then the next one 120 milliseconds, and then 100 milliseconds and 55 milliseconds. And on the private side, it would always be 45 or 46. It would always be like better, but also more steady. Right, so that was, I thought, very interesting, and the app team saw similar stuff there. Yeah.
Different security that the HTTP traffic maybe is going through, causing the jitter on the public side. Is that possible?
Yeah, that's definitely possible. Although interestingly though, I didn't, for that specific baseline test, when I created the public endpoints, I didn't even put a WAF on that because I had an ACL on there. I knew exactly where the request was coming from. So yeah, that is something that probably would be an interesting deep dive into as a follow up of why would the public networks have that oscillation, right? And the other the other interesting though with even with ICMP, you have to also be careful when you ping certain things. You have to make sure they're not being anycasted, because, like, for example, if you ping Google's 8.8.8, it's always comany back at less than 10 milliseconds. So if somebody gives me an endpoint on Google and I ping it, I'm like, well, I'm not going to do better than 8 milliseconds. There's nothing I could build that's going to make it. But then I realized, okay, wait, what am I pinging here? I'm pinging Google's Anycast address. Give me the server behind that, because if I start graphing these great times behind the Anycast, in front of the Anycast, I'm never going to beat those times. So that was an interesting kind of quirk that you have to make sure you're also monitoring the correct endpoints and not, the front end endpoints as well.
Like a tip.
And then, lastly, as far as improvement or wins, the soft wins, which would, team collaboration, across different missions. So if you think about it, at least if I think about it, I've worked with some people maybe for multiple years, 4 or 5 years. I say hi to them on the floor or in the cafeteria or maybe at a vendor event. But you don't really have work conversations necessarily. But when you work on projects like this that run across many different missions, you kind of, build with people, you build a response with people, and you create these relationships and you communicate with people who maybe you don't always communicate with. So I think there's definitely some positives there.
That is the truth. And you can really break down some barriers if you say the department you're in is got a bad reputation for whatever reason. A project like this, you can work with people in other teams and really build some bridges there. And we're good people just like you. Hey, we all want to succeed with this project, right? Let's get things done, and not blaming and not finger pointing, but actually working together and grabbing some whiteboard sessions and chatting and making a commitment to deliver on a thing that was maybe a little bit above and beyond what you needed to do. But then you do that, and that person's like, oh, awesome. Thank you. And you really can use a project like this to make things better inside the org.
Oh, yeah, 100% for sure.
I mean, it sounds like you already had a sense of some things that were going on inside the DevOps side of the house, because you could come to them and say, I see you using Datadog. I see you using Terraform. I'm going to try to meet you there. Yeah,
well, and that's kind of right. That's kind of been my personal mission as far as for the kind of the enterprise networking team, that I've been trying to do. And just I used a project like this to even leverage that even more, right? So we have the on-prem enterprise network, and how can we make that more DevOps-y or more platform engineering-y? But at the same time, if we're doing net new projects like this, you definitely don't want to start in the old paradigm of what we talked about before, which is just taking a solution, throwing it over the wall. Okay, I'll make it work. Here you go. Come back to me when there's a problem. You definitely don't want that. You want to at least start from the right foot, I think.
All right. Well, if you're still with us after this conversation, and I think it was every minute of it has been really worthwhile, thank you. And thank you, Kaon, for joining us. This was a fantastic conversation. If folks are interested in connecting with you online, where should they go?
LinkedIn would be the best place to find me. KaonThana. You could search me, and I'd be happy to connect. Thank you for having me.
Sure. Yeah, we'll have Kaon's LinkedIn in the show notes that accompany this podcast. Thanks, Kaon, for being here. And as always, thank you for joining us for this episode of Heavy Networking today. It's part of the Packet Pushers network of podcasts, blogs, newsletters, and videos for your professional career development. You can visit packetpushers.net or search for Packet Pushers in your podcast client, and you'll find all the shows we're publishing these days. You can also join our absolutely free for everyone Slack channel. As Ethan mentioned, there's over 3,000 IT cloud DevOps and networking professionals just like you in that group. You can take part in the conversation. It's a marketing free zone. You can ask questions, get feedback, and share your own opinions and knowledge. The link to get there is at packetpushers.net/community. We would love to see you there. Last but not least, remember that too much networking would never be enough.